On the screen here, I have a position calculator. So this saves a lot of time with trying to do all this by hand. It can reduce errors when you're trying to figure out more than one or a few holes. You can just punch everything into this Excel spreadsheet and it's going to do all of the math for you. Now, you have to put the right numbers in and you still have to do the right kind of inspection on the plate and not make any mistakes there. But this is going to essentially eliminate mathematical errors. It's going to make your inspection process a lot faster. Now, let me explain how this works real quick. Anything in blue is a number you have to enter in. So when I click on this and I look up here, there's no function going on. This, for example, measured value X is what you're going to read directly from your height gauge. It's the distance from the surface plate plus the gauge pin. Now, the next thing, dimension X, is going to come from your drawing. So I'll bring this over here. That's going to be your basic dimension right here. And in this case, the basic dimension coming from Y is 1/2 inch as well. So I can move over here. The actual hole diameter is going to be the size of your gauge pin. So they mean the same thing. The largest gauge pin is going to be your actual hole diameter. The MMC diameter, you have to do a little bit of arithmetic. It's going to be this number right here, 2.250 minus 4 thousandths. So that's 0.246. That's the smallest this hole is allowed to be via the limits of size. Okay. Next up is the specified tolerance, 0.007. That comes from this right here in green in your feature control frame. That's the specified positional tolerance. Next, we're going to use Excel to calculate some things for us. So first thing is the location of the axis from the datum. Now, we figured this out, this X value, by taking what we measure from the height gauge, this, minus 1/2 of the actual hole diameter, or the gauge pin diameter, means the same thing. So the function for this, if I click on here, is B4, so measured value X, minus parentheses J4, which is the actual hole diameter, divided by 2 parentheses close. And what I can do here is I'm going to copy everything in blue so I can just do these equations over again. So I'm selecting both of these. I'm going to grab this corner and pull down. So I mentioned before, everything in blue we entered in, so there's no equation. So let me go ahead and do this one. I'll type in equals. So this is X. I'm going to click on B5. So we want B5 minus parentheses. I'm going to click on actual hole diameter, backslash 2, close parentheses, hit enter, and that'll give us 0.503. Okay, and I could do the same thing over here. Equals measured value in Y minus parentheses. I'm going to select actual hole diameter, backslash 2 parentheses, hit enter, right? And the numbers are the same. That's exactly what we're looking for. Next up, delta X. So this is the variation. It's essentially, well, it isn't essentially, it is the difference between the basic dimension, the drawing dimension, and the location of the axis in X or Y. So how we get delta X, we're going to do equal sign, basic dimension in X minus the location of the axis in X. Okay, and do the same thing for delta Y, equals the drawing dimension minus the actual location. So we got those under control. I can skip these. Again, these are numbers that we're going to enter in. Bonus tolerance. So how do we calculate bonus tolerance? We need the actual hole diameter and then the MMC diameter that we figured a few minutes ago. So the bonus tolerance, I'm going to hit equals the actual diameter minus the MMC diameter equal sign. That is the bonus tolerance we have. Okay, so as the whole gets closer to MMC, so say I go over here and change this, say it came in at MMC, there's 0 bonus tolerance. Say the whole came in big, we'd get more bonus tolerance. So this number changes as we, enter in different numbers here. Okay, so I'm just going to bold this. Next up, allowable tolerance is just the specified plus the bonus. Okay, so I'm going to hit equals, specified, plus sign, click this, bingo, allowable tolerance. Okay, and then the diameter of positional variation is a little trickier. So I'm going to select right here and show you what we got going on. We need 2 times the square root of delta x squared plus delta y squared. How I like to do equations in Excel is start from the inside out. Okay, so what do I mean? Let's do delta, let's do equal sign, delta x, we're going to do the caret 2. So the little caret, you can see it up here, squares that number. So I hit enter. And if you're wondering why it reads 0, it's because there's not enough decimal places. So I'll go up here to the increased decimal until we get a significant figure here. So it's a bunch of zeros and a 9. Okay, so we got that under control. Now let's put this in parentheses. We're going to do plus. We're going to do a parentheses. Now we'll square delta y, shift, caret, squared, parentheses. Okay, I hit enter. What I'm doing here is making sure each part of the equation works before I go to the next part of the equation. Okay, if you try to do it all at once, you can run into an error and not be able to figure out what's going on. So we got that under control. Now we want to do the square root of all of this. So I'm going to put the whole mess in parentheses. I'm going to come out here, type in SQRT, and hit enter. Okay, that gives us the square root of that. Now the parentheses are really important. If you don't have this outside set of parentheses, it could take the square root of this right here and then add this. It's a different meaning. Okay, I hit enter. Now I'm going to go back. Now we've got to do 2, little star symbol, hit enter. That is the diameter of position variation. When you're making a spreadsheet like this, I recommend you do it by hand on paper and make sure you get the right answer. Now, once you got the equation set up in Excel, you're good to go, but it can be tricky when you're dealing with square roots and you got all these extra parentheses, right? And then the last thing, we can have Excel do an if function. So if this diameter, the actual diameter of positional variation, is larger than the allowable, the part is rejected. If it's smaller than the allowable, the part is acceptable. So I'll click here and show you what we did here. If allowable tolerance is greater than or equal to the actual positional diameter, we accept. If it's smaller, if the allowable tolerance is less than the actual tolerance taken up, then we reject. So let me show you how we do this. Hit enter. I'm going to do if. So it gives you little instructions right here. So what's the logical test? The logical test is this box right here, allowable tolerance. If it's greater than or equal to this, we're hit a comma. If that's true, right here, see it's in bold, we're going to do quotation marks. That's really important. We accept. Remember the quotation marks. We got to do another comma, just like it's showing me down here. So if it's not true, then we're going to do reject and then quotation. And you could put anything you want here. You could put your part sucks, right? And then parentheses, hit enter. So let's see if this works. Let's change this over here, measured value. Let's change it to 0.65. Hit enter, right? It does the calculations all through here. The diameter that's actually taken up is much larger than the allowable, and then it's going to read your part sucks, right? So you can have it tell, you know, spit out anything you want. The important thing is this is all set up, right? When you change these numbers, it's going to change down here. Now, if you have a whole bunch of, you know, holes to check, so I'll change that to 1. If you enumerate this, so let's get 1, 2, 3, pull this little green box down, it's automatically going to number these for us. Now what we can do is copy all of this. All right, so we got the same equation for all these holes. So you could go in and change these and just enter in all this information. So what we could do, delete this. We can go ahead and delete the measured values, the dimensions. Delete the dimensions on the drawing. The MMC diameters, we'll assume those are going to stay the same. Assume the specified tolerance is going to stay the same. We won't worry about this right here. So now you go through and you just enter in the numbers from your height gauge. You enter in the basic dimensions. So in a part like this, you know, you're going to have a couple different basic dimension combinations that you got to figure out. Okay. Yeah, the gauge pins might change depending on the size of the holes. You want to punch that in, but eventually it's going to spit out the diameter of positional variation, the allowable tolerance, and whether the part is acceptable or not. So that's a basic position calculator. It's really handy to have if you're checking a part for position. Does it automatically. You can print it out. You can, if you wanted to show your formulas for whatever reason, hit Control and then the tilde key at the top of your keyboard. Okay, so if you wanted to double check your equations or see what somebody else is doing, if you got to, you know, turn something in for an assignment, it'll show you how you're calculating everything. Okay, so I'm gonna hit Control tilde again. If you're going to print this, yeah, you might want to make sure it's going to print correctly. You know, you should fit it to your paper. But that's about it for this video. If you enjoyed it, please like and subscribe. I don't normally make screen capture videos, but there's no other way to explain how to do a position calculator on Excel.